Hello Internet. In this video we are going to be taking a look at a usability or user experience feature that I like to add to some of my graphical interfaces, I guess. We're going to be doing this in Unity, but I've done this in all sorts of other things, from websites to other things. And typically I use it when I need to highlight large amounts of data that can all end up kind of looking the same. And so what we're going to be doing, I should probably talk about that because otherwise everybody's going to be confused. We're going to be adding color to each of these strings. And so what we're going to be doing in order to do that is we're actually going to be taking a hash of the string of the value there, and then converting that hash into a color. And so we're going to be doing this in Unity. You can do this in any language. You just may need to do the hue shift math yourself, but there's plenty of functions for you to figure out how to do that. We're not going to be using any Unity specific code other than the color stuff and the text rendering. So this should work anywhere. I like to do this because it makes it a lot clearer, especially when text starts to look the same, that things are different. Because we're taking a hash, the purpose of a hash, I guess, is to calculate, given any sequence of data, it is intended to give you a unique identifier for that. Obviously, because a hash is shorter, it's not always going to be unique, but it's unique enough that you shouldn't have duplicates unless something really weird is happening. And we're talking about color anyway, so there's going to be duplicates. The point of using a hash instead of just like adding up the values of the characters in a word is a hash is intended not to show those kinds of patterns. So if we have something that differs between an A and a B, for example, that's only one value different. And so if you're just adding up all of those colors, you're not actually really changing that much. And if you have a string that is AB and a string that is BA, now those are both the same color. In this situation, unless things are exactly the same string, they should be relatively distinct from one another, unless there's a conflict that we introduced somewhere else. This is not really something you can predict because of the way this ends up working, but I found it's pretty good at getting things unique enough where you don't get overlaps if you do this enough. So anyway, we're gonna code this because it'll be easier to see once we actually start doing this. I've already done a little bit of work. The script's over here, but this is using TextMesh Pro, and so all I have is something to pull out the text. And in order to do all of this I guess we could do this in the start. We're going to first need to get a hash for the value in our string. Again, a hash is just a unique identifier for whatever it is, or intended to be unique. They're used in all sorts of things for validating like a file is what it's supposed to be, and things like that. In this case, we're just taking a string and converting it into a unique integer. This is a multi-step process because hashes aren't, by definition, integers. They're typically just arrays of bytes. And so we actually need to do some conversions here. But the first thing is we need a hasher. So we're just going to use an MD5 hash. So new, actually not new, sorry. I do have notes for this because I don't work with cryptography stuff much. And so we're going to have some notes. But we do have MD5.create. This is going to create a new hashing MD5 object. And we're going to use that and actually compute the hash. So var hashed value. And so we're going to take the MD5 hasher that we created, and we're going to compute the hash. This is going to return a byte array, which is just a series of bytes. Hashes can be any length long. You might have seen like SHA-256, for example. That's where that number comes from. So this could be any length. We don't really care about that. Because again, the purpose of this is not to use all the data there. It's just to get us give an extra bit of useful information to the user so that they can distinguish these overlapping things. And this doesn't just have to be colors either. What I'm showing here can work for pretty much anything you do. We're going to take the text.text Why doesn't, oh, okay. This doesn't work. We can't just provide a string to this. This actually expects bytes. So bytes in, bytes out. What it's going to do is take that sequence of bytes and shrink it down into whatever the hash is, effectively running all of the cryptography over whatever those bytes are. And so what we need is we need to use this encoding package, and let's import that. And so this includes a whole bunch of different things. There are a bunch of different encodings that you can use. UTF-8 is a pretty common one, I guess. That's probably the one that you want to use here. And so we're just going to use that and get the bytes from that. This lets us pass in a string, convert that into bytes, and then get those bytes and pass that into our hash. This is the most confusing part of this entire thing. Effectively, we are shrinking some value into some computational representation of what it is. And then we were converting that into some smaller thing. Effectively, we're reducing it into its hashed value. And then after that, we need to convert it back into whatever it is. So there is a, what's the word I'm looking for? There is a function called the BitConverter. So this will be our converted value, and we want to do a bit converter. And so this is actually part of C#'s system libraries. This allows you to convert byte arrays to pretty much anything, and also lets you convert 2-byte arrays. So we can convert to characters, to doubles, or to integers. That's what we're going to be doing here. So we're just going to do toInt32. And we just need to provide the hashed value, which is going to be the hashed byte value. And then we're just going to give it a start index. This doesn't really matter for us. So we're just going to give it 0, the first index. And so that is now at some random integer. We can actually make this public. Int value, sure. And we'll just save that out for now. Before we get into the next step, just so we can kind of show what's happening. These are probably going to be very large numbers because this is just going to be over the entire space of integers. It should not all be like between 1 and 100, for example. This should be much, much larger. That's just sort of the nature of how this is going to work. That's also part of why this is nice. Because we're making the space so big, there's typically drift between small changes. Granted, in these samples, I didn't actually introduce any small changes. So we may have to change one of these just to show us changing. But this should run. I'll also ignore this. This is in a separate project, and so it's also using my microphone and picking up my voice. But we're gonna ignore all of that. That's something that's coming later. So surprise sneak preview. But you can see we're getting like these massive negative numbers. We're getting more massive negative numbers, even more, very large negative numbers. But they're in like the millions, or this is, like 94 million some value. It really doesn't matter once we get to that point. What we're really trying to do with this is actually get something more useful out of this. So I'm going to stop this because otherwise it's just going to keep doing a whole bunch of stuff. Let's use this for something. So Unity provides a Color.HSVtoRGB function. And so what this is going to do is given a hue, saturation, and value, it is going to convert that into a Unity color for you. And so what we want to do is provide this value as the hue. What that's going to do is shift between all the colors of the color wheel in pretty much a continuous circle to give us different colors. There are better ways to do this. There's more complicated ways. Part of this is going to be you typically want the colors that you're generating to have the same brightness. And red, green, and blue are perceived differently. And so certain colors are I believe red is dimmer than blue, for example. So you will see more blue than you will red if they're the same value. And so you typically want to reduce the value of blue and increase the value of red. There's some math somewhere that talks about this. I don't remember it, and we're not going to do it here, but that could be something to consider. You can make this as complicated as you want. Really, all we're doing is converting some fixed known value into another one that is repeatable, but it's doing it in a random way. So say usernames, for example. If somebody has usernames and you want to assign each player a I can't say unique because these won't necessarily be unique, but you want to assign a player model based off of that player's name. This gives you an option to do that because you can have 3 different players or player models, for example, hash them and then take this value and just mod it by 3. And now you have 0, 1, and 2 as your values, and you can just plug those into your models and do a lookup table and pull them out that way. So this gives you a way to kind of play with all of those. In this case, we're going to convert this into a float. And we're still going to use this mod just because we don't expect things to go all the way up to the max value. And this gives us a clamp, I guess, on this. So let's do var color equals our color dot RGB to HSV to RGB. So the saturation is what's going to give it the color. If we don't do a saturation, this is pointless. So we're going to make sure that's 1 for this. That might be too much, but it'll be fine. We'll do, I always forget what I like for these values. With a lot of this, it just helps to kind of tweak it until you find something you like, and then it's probably good enough. That's how I do it anyway. Hue, we need to convert this value into some range. So we're going to mod this by, let's see. Let's mod it by 2. It really doesn't matter that much. 256. So we have 256 values now that can be the result of this. And we are going to plug that or divide that by 256.0f. And so what this is going to do, after I fix some of my math, we're going to add an absolute value here because we do have negatives. This just makes it more explicit. Why doesn't it like that?
A few moments later.
Parentheses can be removed. Okay, oh, there we go. It added an extra parenthesis for me. Thanks, but no thanks. All right, so we have this absolute value here because things can be negative. That just makes it more explicit. We're going to mod this into 256 different unique values. This mod effectively gets the remainder. And so that means that even though we have these really large numbers, we're actually shrinking this down between 0 and 255. And then we're dividing it by the total possible values. So 256. This could be 255 too. But that would actually generate an additional option for red. Red being 0 or 1. Because it's circular, what would actually happen is if you get 0 or 1, it should be the same, if I'm understanding everything correctly. And so we actually don't want there to be a possibility for you to get 1. So there's 256 steps in this circle, and effectively this function is taking those steps based off of the value. So for every 1 in the value, we take another step around, and we just effectively repeat that as many times as we need to until we run out. So that's how this is going to work. We get the color, and then we just want to do text.color equals the color. And this is just going to assign it to our text in our UI. And so we should be able to run this now and get unique colors. I do have duplicates here. So there's 2 world of zeros here. And we should expect those to be the same color. But others you can see are different. C# and are fairly similar. And like, comment, and subscribe. Hint, hint. And world of zero are also fairly similar. But again, we have 256 values. So you're going to get values that are close to one another, but aren't necessarily going to overlap. But hopefully this kind of makes it a little bit easier to distinguish when things are unique. For example, because we're doing it this way, because we're actually serializing the strings or hashing the strings, we should be able to change this like, comment, and subscribe thing into world of, let's do of with a capital O 0. So those are two different strings, and they're fairly unique. We should get two different colors here, and we do. And so the useful thing here is this way, it's much easier to see that those are different values. And so you're not going to confuse them for the same thing. And if you reboot this program and rerun it at a different time, unless your algorithm has changed, you should see the exact same results every time you run this. There's no randomness here. And so because this isn't random, this is a repeatable thing. So if you're trying to do this for websites, for example, you can always recreate the value that you want for that website. So that's something that I've explored before, is just using this to create that. Again, this doesn't have to be how you do this. You don't have to plug it into a hue, saturation, and value and do that color wheel thing. You can also just have like a list of colors and just index into that list using the hash. That's an option too. You can do this however you want, but hashes kind of give you a way to do pseudo-randomness, where you're getting random values, but they're seeded from a predictable result, similar to actual random values in this. You're just not using a random seed. So I guess that's all I really wanted to cover here. It's a relatively quick and easy thing to do. But for some things, when you just have a lot of text, I found it useful. So I figured I'd share. Plus, we got to explore hashes, and those are not something you always get to touch. So if that's something that you're working with and you have other use cases that you're using, probably something more related to like cryptography or something. One, probably you aren't using MD5 anymore. But also just let me know what you're using it for, because I'm curious. So I think I'll leave it here. This is pretty much everything I wanted to cover. So I will see you in the next video. So until then, see you, Internet.